Hello everyone. Today I'm gonna take a look at RIP protocol, routing protocol. So very basic protocol, and we can say this is distance vector routing protocol. So let's get started. First we will talk about RIP overview. Second we will talk about RIP version 1 and version 2, the comparison between these. Loop prevention mechanism in RIP, advantage and disadvantage of RIP. So first let's understand RIP overview. So RIP is a distance vector protocol that says how far and in which direction we want to send the update. So RIP uses Bellman-Ford algorithm, and we can say routing by rumor. So routing by rumor says the information, whatever information coming from neighbor, believe in that. So whether the information is correct or incorrect, devices they believe in their neighbors. So the algorithm which is used by RIP is Bellman-Ford. So there are two versions, version 1, version 2, and the documentation for both I have mentioned here. We can go and we can see over there also. So generally RIP is designed for a small network. It's not for very big, not for ISP. We can have this type of configuration in our private network or in very small network. RIP uses protocol number 520, which is UDP. So UDP is the protocol used by RIP. Protocol number we can see in update. The administrative distance, a kind of value trustworthiness rating for all the routing updates. So whatever protocol you configure, that protocol has a kind of rating value. So based on this, devices they decide which protocol they need to use. So for RIP it's a 120. So if you have EIGRP, we have 90. So in this case lowest is always better. So administrative distance, lowest is always preferred. The metric value, which is again a numerical value, based on that devices they take decision and define the best path. So metric value for RIP is hop count, maximum 16. So 0 to 15 is the hop count value, and the algorithm which is used by RIP is Bellman-Ford, routing by rumor. RIP sends periodic update because all the devices they need to tell all the neighbors what information they have. So whatever information they have, they need to tell their neighbor, and neighbor they need to tell their neighbors. So distance vector protocol again sends update, I can say periodically update again and again. So every 30 seconds is the time default timer value for RIP, and they send the whole database. It's not whatever the changes occur. Whenever information, whatever information comes to the neighbor automatically updates that information along with the database whatever the neighbor has, and send it to their next neighbor. So periodic updates 30 seconds. There are two versions, version 1, version 2. Let's understand the comparison between two. So RIP version 1 is a classful protocol, and there is no authentication in RIP version 1. So we need to understand first what is a classful. Classful routing protocol, they do not send exact subnet mask, whatever subnet mask we configure, manual subnet mask, they do not advertise that subnet mask in their routing updates. So whoever the neighbor, if they get the update, they are not aware what exact subnet mask we have. So this is the classful, and that's why it's not a scalable protocol, does not provide any authentication. And whenever RIP version 1 configured device sends update, that sends as a broadcast message. So it sends to everyone. So update will be in broadcast format. So as we can see, the packet format, update format, where we don't see any network mask in this update. So whatever information goes from RIP version 1 configured device, that does not have the exact subnet mask, so it does not support VLSM as well. RIP version 2 is a classless, but by default is again classful So we need to uh, make RIPv2 understand to behave like classless. We need to give a separate command and we need to enable that feature. So RIPv2 is a class full by default, but we can make it as a classless routing protocol. Then RIPv2 sends update as a multicast and the address is 224.0.0.9. Does support authentication. There is an authentication between neighbors. They can authenticate each other. So simple text and MD5, both types of authentication it does support. So here we see classless routing protocols, they do send subnet mask in their routing table, routing updates. So whatever updates they are going to prepare and they are going to build, they build with exact subnet mask and they forward it to their exit interface. It does support VLSM because of course it does advertise proper subnet mask. There are 4 types of timers in RIP. I can say update timer, which is the default 30 seconds, invalid timer, hold down timer, and flush timer. Update timer every 30 seconds, all the devices they tell everyone or directly connected devices about their updates. Invalid timer, if anybody who is not sending update till 30 seconds, then device is going to mark that route as an invalid route. So the timer starts after 30 seconds till 180 seconds. When the 180 seconds expire, then the hold down timer starts till 240 seconds. So in invalid timers, router marks the route entry which is not available, or the information we did not learn from neighbor, mark that entry as invalid with hop count 16, so unreachable. When 180 it goes beyond 180, then router waits for some time and sees if any neighbor who knows about the route which I did not learn from my neighbor, who knows about the route, and that neighbor sends the same route via another path. If the neighbor the information coming to me has the lowest metric, then the router is going to update this entry. So let's take an example here. This is one router here. There is a link 1.1.1.1. There is one more router which is connected like this. So this router has 1.1.1.1 and this router learned via this router, and this is learning via this also. But router is going to update this and going to say metric value 1 hop. So if this link goes down now, in this case what will happen? So this router did not advertise 1.1.1.1 to this router till 80 seconds, till 180 seconds. Then this router is going to start hold down timer and going to see, okay, I have this route, but still I am waiting if anybody knows. So in this case, this router knows about that entry. So this router is going to send this entry to this device. This device now says, this router says, okay, whatever information you are sending me, that is coming with metric value of 2 and I have the metric value is 1, so I will ignore your route. I will not believe in you. So it will automatically ignore it, because in hold down timer it says the current metric must be the metric value which we are learning from the neighbor must be lower than the current. So right now 2 is higher than the current, so it will ignore. Then the last is flush timer, which is to remove this garbage and flush out all the entries which you did not learn till 240 seconds. There are loop prevention mechanism we use in RIP. Because of the timer value of RIP, all the routers sometimes they get confused and they can believe in their neighbors and can make wrong decision. So we can define manual hop count value for particular network. So whatever information we are learning from neighbor, we can define a metric value which may be unreachable. Hold down timer again. So I would say here the hold down timer says this line. So I would remove this. Believe in route which is coming with lowest metric than current. So hold down timer says you are learning the same route which has gone down via another network or another neighbor, but only update when the metric value of that route is lower than the current. That's it. Split horizon rule, which is router whatever information we are learning from the neighbor, do not advertise back to that neighbor. So very simple example I would give you here, like frame relay environment, where this is the scenario. So I have 1.1.1.1. so this router is sending update to this router. This router says I learned from this interface, I will not advertise back to that interface. So this split horizon rule will deny the route going toward the originating interface. Route poisoning or poison reverse, I would say when you learn a route or the route goes down, immediately router marks that route unreachable and send it to everyone. So here I say 1.1.1.1 is not available. This router is going to say this is not available, then mark this one as 16 and send it to everyone. So all these devices, they will not look for that router, they will say this is unreachable. So route poisoning also is a feature to prevent loop in a RIP. There is trigger update also. The trigger update will update immediately if any changes occur in the network. So some advantage I can talk about RIP is simplicity, low resources requirement. We don't need very high configuration router, we can configure in very basic simple router. Minimum link bandwidth, RIP does not require more bandwidth to send their updates, but as the network grows, then there may be a cause or the issue we might face because a lot of RIP updates, periodic updates will go here and there. The disadvantage of using RIP is slow convergence in very big corporate environments. So ISP, they don't prefer to use RIP because of their slow convergence. Second I can say is limited scalability. As I have told, this supports only maximum 16 hop counts in a queue. Potential for routing loop, sometimes loop may occur if we don't configure it properly and the timers are not configured properly. Some commands are there to configure RIP, very basic commands. We will talk about that and we will configure RIP and we will understand that. RIP can send update in multicast format, in broadcast format and in unicast format. So in multicast by default version 2, but we can send in broadcast as well. So broadcast update in version 1 by default, but for version 2 also we can send updates as a broadcast. There is a special command IPRIP version 2 broadcast. Unicast, if you don't want to advertise updates in multicast format, and unicast in the environment where the firewall does not allow your broadcast and multicast whatever we are forwarding there, then you can apply there unicast updates, and the command will be neighbor. We will talk about this as well. Now we can go to the configuration part and understand how we can configure RIP. So here is my topology. I can say router 1, 2, 3, 4, 5 and ISP. So router 1 is connected to router 2 and router 3 via DM VPN cloud, and there are two computers, two Windows machines. Router 4 and router 5 are client of router 2 and router 3. So as I have drawn the diagram here, IP connectivity is already there in all the devices. We need to configure RIP and need to understand the basic fundamental of RIP. So let's start configuration on router 1. So first we configure, we can verify the connectivity, but as I have told, I have already configured IP addresses and I have checked the connectivity between directly connected devices. So first I will configure RIP version 1 on router 1. So very simple configuration. We need to understand total number of directly connected devices here in the version 1 on router 1. So total number of directly connected interfaces are faster than at 00 and faster than at 01. So I would go there and I would configure router RIP. The command is router RIP. So so command is router RIP, and we can give network and the network ID or IP address. It will automatically take as based on class. So I can say router 1 has 3 interfaces: 172.16.00 which is DM VPN, 192.168.1.0 which is this, and there is a loopback configured on router 1. On router 2 we can again verify how many interfaces are there. So we need to give those number of interfaces entry. So there is a command show IP interfaces. I can say 1, 2, 3, 4 and 5. So this is my public IP for DM VPN, so I would not give this entry. Rest all entries I would give. So I can say 1, 2, which is 25, 3. So we don't need to give separate entry for that. We can directly go and give this command. Sorry, I would not give this. So router RIP network 172.16.00. So router 2 says DM VPN hub also has the same network, and serial 1/0 has the same network. Come to router 3. Router 3 would say router RIP. There are again, I would say, 3 networks directly connected and 1 loopback on router 4 and 5 now. So on router 4, router 4 also has 2 interfaces here, and last router 5. So router RIP on router 5 as well. As we can see, we have configured RIP on all the devices. Let's verify everything on router 1. Some verification commands I would type here. How to verify? So first command show IP protocol. This shows me a lot of information. Let's take it up. So what information we have here is outgoing update filter list that we have not set. Here is the timer value 30 seconds, invalid timer, hold down, flush timer value. When we give this command, we have here faster than at 01 on router 1, which is this, loopback and tunnel. So these are the interfaces where we are advertising RIP updates on tunnel, loopback, and so by default I am sending version 1 update. I am receiving version 1 and version 2. So version 1 can accept the update coming from version 2 by default. Automatic network summarization is in effect, that says automatic summary is enabled. Maximum path for load balancing we can have 4 here, and the networks which we have advertised on router 1, these 1.0.0.0, which is the loop back of router 1, and these are the interfaces directly connected on router 1. Distance value for router 1 is 120. Let's verify what's happening on router 1 now. So I can see show IP route to verify routing table, show IP route RIP. So router 1 did not learn anything. So we can see here how many networks are directly connected. These networks are directly connected, but router 1 did not learn anything from router 2 and router 3. Come to router 2, show IP route RIP. So as we see, router 2 learned 1.0.0.0/8, router 2 learned 5 and 5. So I can say router 2 learned 5, which is 5 here and which is 1 year. So from 1 and from 5 router 2 learned. Router 3, so router 3 learned here 4 and 1. So came from 1, okay, 4 also, that's okay. And 192.168.1.0, which is this. Okay, come to router 4. What information we see in router 4? Show IP route RIP. So as we can see, we are learning information from router 3 here, learned via router 3. But as you can see, the subnet mask for all, even I have subnet mask is different on router 3 and router 1. So I have the loopback. These loopbacks are configured with /32, but here we can see only /8. Come to router 1 and see what exactly is subnet mask for that. So I can say show run interface loopback 1. So as you can see, loopback is configured with /32, but we are not learning /32. Now we can verify with the debug what's happening in these devices. So I say debug IPRIP to verify what information we are learning and what information is being forwarded toward these devices. So the timer value is version here is saying illegal version. So I think there is a command already configured on router 1, that's why it's giving illegal version. So if we can verify, it's a very interesting troubleshooting command. We can see here update is going, sending version 1 update to this IP. So that is broadcast IP. But we are ignoring because we are receiving with illegal version. I will show you what is the solution for that, but we are sending with broadcast IP. So let me verify what is the problem here, why we are not receiving. So there is a command I have given already, was on the tunnel interface. I need to remove that. So let's remove this and this. Now we are going to learn updates coming from router 2 and router 3. So this time we will learn. So there is a tunnel between router 1, 2 and 3, is a tunnel 0. So as we see now, all the updates are coming, but we see here updates are coming but not coming with exact subnet mask 2, 3, 4 and 5. They have /32, but they are not coming with /32. So the issue here, as I have shown, RIP version 1 does not send exact subnet mask in their updates. So we need to configure here RIP version 2. So before going to RIP version 2, I would show you router 2 and router 3. They must know about this network and this network. So I am on router 3 and I verify router 3 must have 172.16.25.0. So as you can see 172.16.34.0 which is directly connected here, but router 3 did not learn route this route in routing table, and router 2 did not learn 172.16.34.0 because of the split horizon. Split horizon is by default enabled on this interface, tunnel interface. So I say when the update is coming from router 5 to router 2 and router 2 is advertising it to router 1, which is my hub, the hub is not advertising it back toward that interface because of split horizon. So if I come to router 2 also, I cannot see 34 here. As you see, no 34 because of split horizon. Router 1 is not advertising, but router 1 is learning about all those. So as you see, router 1 has 34 as well and 24, but it's not allowing back to that interface. How to disable and how to verify whether the split horizon is enabled or not. So show IP interface tunnel and tunnel IP. I have configured tunnel between these. So the command is show IP interface tunnel, and here we can find out whether the split horizon is enabled or not. So split horizon is enabled. I need to disable, then we can learn it properly. So this is one factor you will see. So go to tunnel and say no IP split horizon. That's it. Now you verify again. Show IP interface brief, show IP interface tunnel. This time it says split horizon is disabled, and come to router 2. This time verify. So it takes some time to update, but this time you see we are learning all the entries and we are learning 34 on router 2. On router 3 we are learning 25 as well. Yes, so we are learning the routes but not with the exact subnet mask this time because RIP version 1. Let's ping. It will ping router 5. I will ping this machine and this machine. So I have already two machines, Windows XP. So this is my 56 this user is going to ping this user. So I can say here ping 192.168.41.10, which is my this user, and we can see it's pinging. And how is it pinging? We can trace it. (41.10), and we see first this is going to 56.254, which is the gateway here. Router 2 is sending it to router 1, which is router 1 0.1. Router 1 is sending it to 03, which is here, and finally going to this one. So this is verification of RIP version 1, and this does not support I can say VLSM and CIDR. So we need to fix the issue still because we are not learning exact subnet mask, and the issue we can fix this with configuration of router RIP version 2 in all the devices. So I will go to all the devices and let's change the version 2. Go to this device, router 2. Let me go to this device, router 4 and router 5. Yeah, Now I will clear the table of all the routers here, routing table, so we can learn all the new routes. Clear IP route star in all the routers, and we can verify everything on router 1 and router 2 and router. So I can say show IP route RIP in all the routers. So let me see here. So still you see we have not learned the exact subnet mask, even we have configured RIP version 2. So if you want to verify, we can give show IP protocol, which will give me information. Okay, RIP version 1, sending version 2, receiving version 2. But still RIP version 2 also uh, is not giving me exact subnet mask because automatic summarization is in effect. So we need to disable this, then we can learn about this. So let me go to all devices again and says very simple command to disable automatic summarization, so we will not face this issue. Version 2, no auto summary everywhere in all the devices. Now again we can clear the table. Clear IP route. Okay, now we will verify on router 1, router 2, router 3 and router 4. So router 1, as we can see now, the result is here. So we are learning the loopback of router 2, we are learning the loopback of 3, 4 and 5, and the subnet mask is exact. To verify this, we can give here debug IP RIP, and we can see what address this router is using. So here you see the address is being used by this device is 224.0.0.9, which is multicast for RIP version 2. So this is the configuration we need here, and we need to configure, otherwise we will not learn the exact subnet mask in this routing table. So I need to undebug all, and again let me ping from that device. So same device, again I come and I ping. So as you can see, we are able to ping. So this much configuration we require to configure version 1 and version 2. There are many parameters we can configure for version 2 and version 1. So one of the parameter I can say I want to send version 1 update toward this site, or version 2 update. So there is a special command to change the version receive version and sending version. As we have seen, the first time we were facing the issue, we were receiving version 1 update, router 1 was ignoring that. So interface tunnel, I want command to configure interface tunnel, the name of interface, and give the command IP RIP receive version 2 and IP RIP send version 2. So I want to receive version 2 update and I want to send version 2 update. If version 1 update comes here, I am going to ignore. So this is one kind of parameter or the command we can use. Now I can use another parameter. People they say, okay, need to change the timer of RIP, which is a default timer 30 seconds, 180, 180, 240. We can change that as well. So I can change on router 1, router 2. This time I can say right now the timer value is show IP protocol. The by default timer 30, 180, 180, 240. So let me configure the timer for this. Sorry, I have selected wrong thing here. So need to abort this. Okay, so this is not the command. Okay, I'm going to configure this time. So router RIP timers basic. So first is update, second is invalid, third is hold down, fourth is flush time. Let's verify. Show IP protocol, you can see here 10, 40, hold down, flush time. So this is the way we can change the command. The command is timers basic and the whatever timer we want to give here. There is another parameter we can change here, is called passive interface. So passive interface does not allow the router to forward their updates on the interface. So interface which is configured with passive, router will not send any kind of update over there. So I go to router 3 and there is a computer, we don't need to advertise any update over there. So on router 3 I need to configure passive for fast Ethernet 01. So first verify where router 3 is advertising updates or not. So debug IP RIP, let's see, on fast Ethernet 01. So here I can make it big and verify. Serial 1 is advertising receiving here. Okay, so router 3 is advertising sending version 2 via fast Ethernet 01, which is this one. I don't want to advertise this time because there is PC. So router RIP passive interface and FA01, that's it. How to verify this interface is passive or not? Command we can give show IP protocol, and here you see passive interface name. Let's verify whether router is advertising or not. Debug IP RIP. So router will not advertise any update on passive interface. So we will see here sending on tunnel, that's okay. Received from tunnel, that's okay. Sending update to serial 1/0, that's okay, but it's not advertising on fast Ethernet 01 because we have made it passive. Okay, so one more parameter we can configure here is called neighbor. We want to advertise RIP updates in unicast format in these devices. So router 1 and router 2. So router 1 should advertise updates in unicast format, and router 1 should advertise update to router 3 also in unicast format. So right now router 1 is advertising in multicast format, but we can give a command to advertise in unicast format. So I can see router RIP neighbor command and the IP address of neighbor. So 172.16.0.2, that's it, and 3, and we can verify this time. So debug IP RIP, and we verify here. So router 1 is sending, here is the address which is to router 2, received from router 2, sorry, and going to send received from router 2, and here I can see and debug all here, and he sending to tunnel 00, okay, fine, received from this as a unicast, and sending to loopback, received from loopback. I need to just check it again. Here sending version 2 update to 172.16.3. it's not like sending version 2 update to this, and here sending version 2 update this time with unicast address, not with multicast address. So we can verify like this as well. So very most important command we can use is debug IP RIP show IP protocol, and show IP route and show IP interface, whatever interface you want to see that, and we can disable split horizon over there, we can enable split horizon over there. So the basic fundamental about RIP is this much. We will come back to the next topic in next series. Thank you for watching this video. Have a great day and bye bye.